So this is another video finishing up chapter 3. This is section 3.3 on rational expressions and equations. The last one was radical expressions and equations, so we're just going to finish this off. We're going to do about 2 or 3 examples. So let's do this one. So what we have to do is we have to find out what our LCD is. So that's going to be our first step. So how do we do that? Well, I look at my denominators. So when we look at our denominators here, and I see y plus 3, y minus 3, and then y2 minus 9. So I know that 3 times 3 gives me 9. So that means that this, so if you ever see something like this squared, we know this expands to this. Okay? So we know that our LCD is going to be that. Y plus 3 and y minus 3. Now our second step is to look for our restrictions. So what does our restriction say here? So if I equal both of these to 0, so it's going to be y equals minus 3 and y equals plus 3. So that means I cannot have it equaling, my final result cannot equal minus 3, and then it can also not equal just positive 3. Okay, so now what we do is we multiply our LCD by each section that we have here. So this would be 1, 2, and 3. So I'm going to multiply it by all 3 parts. I'm going to write my LCD in a different color. So y plus 3, I'm just writing my LCD right now. Multiply it by the first guy. This is number 1. Do the same thing again. There's my second guy. I might run out of room here, but we'll make it do. I'm just going to write this down below. You want to make sure you move that negative. Okay, so our next step is, this is step 3, we want to cross out what we don't need. So get rid what we don't need. So if I look here, I look at my denominators, and I see that y plus 3 is here. So I want to cross that out in my LCD, so that goes away. For this one, I have y minus 3, so that will go away this time. But y squared minus 9 is this, we said here, it's the same as our LCD. So that means what's going to both go away is both of them here. So we're left with minus 3. So now what we do is our fourth step is combine what's left over. So now I have 1 y minus 3 minus 4 y plus 3 equals minus 3. So now what we want to do, so we want to simplify and then get it in a quadratic form to solve. So let's see, I can distribute both of these. So I got 1y minus 3 minus 4y, and then negative 4 times 3 is going to give me 12, but minus 12 equals negative 3. Well, still not done yet. I want to move this 3 to the other side. Equals 0. So now we're equal to 0. Now we can combine like terms. This is kind of going back to the last section that we did, the last video that we did. Combine those like terms. So then let's see. So I have 1y and minus 4y. So I have 1 minus 4. I get minus 3y. Is that right? Yeah. So minus 3y. And then, so that means these two have taken care of. What about the rest of them? So I'm going to do, let's see, minus 3, minus 12, plus 3. Yeah. So minus 3, minus 12, plus 3 gives me minus 12 again. And then that equals 0. So then what do we do? Well, I can move this 12 over to get the y by itself. Divided by 3, or minus 3. That gets rid of this guy over here. This is going back to basic algebra. So 12 divided by 3 is going to give me negative 4. We have to carry that negative. Okay. So this is our solution. And then, so our fifth step was simplifying. Into quadratic form to solve. So I know there's more steps than what he gave you in the book, but this is what I would do, just breaking it apart into each step so I understand what's going on. So again, we found the LCD, we did our restrictions, and then we've got rid of what we didn't need anymore. Crossing it out, we've combined what's left over, so we combined the like terms. After we finished that, and then we simplified into quadratic form to solve. But let's look at our restrictions. So this solution will work because our restriction said it couldn't equal minus 3 and I couldn't equal plus 3. So this solution works. So let me highlight that. Yes, it works. Okay, let's do another one. So let's do 8 over y squared minus 1 So before I even start doing this, I want you to try solving this on your own, pause the video, work on it as long as you need, and then come back and watch the solution. So we're going to do that for the next two. Try them yourself and follow the steps that we did here and see what you get. Okay, welcome back. So let's go ahead and walk through this problem. Hopefully you got the same exact solution that I got. So first step, LCD. So what's my LCD? Okay, so I have y squared minus 1, y plus 1, and y minus 1. Well, same thing again. We know that this is equal to this expanded. So this means that our LCD is y plus 1 and y minus 1. So now we can find our restrictions. So our restrictions say that we're going to equal to 0 and then find out what it won't be. Well, this one's pretty easy to equal to 0. It's just saying it's just going to be y cannot equal minus 1 and y cannot equal plus 1. So same example as the last one, really. So now what we do is we set up and we multiply our LCD by the original that is there. So y plus 1, y minus 1. This is our first guy. So we're still multiplying by the LCD. I know there's not very much room here. Okay, so now we just do our third step. So we cross out what we don't need, cross out. So on the left-hand side, I notice that I have the y2 minus 1, so we know that's the same, so both sides get crossed. Y plus 1 gets crossed, and y minus 1 gets crossed. So now, combine what's left over, so that's number 4. Combine left over. So I just have 8 here in the number 1 position. So now we distribute. So now that we combine, now we can do everything on one side to equal to 0. So let's do that. Move everything over. Remember, when you move to the other side, you change the signs of everything. So let's see. I'm going to combine the y's first. So I have 3y minus 1y. We get 2y. And then we have 8 minus 3 and minus 1. So we have 8 minus 3 minus 1. We get 4. So plus 4 equals 0. So now we need to simplify. Just move that 4 back over. So it's going to be like this. 2y equals minus 4. You divide by 2. And then you get y equals minus 2. So let's see, look at our restrictions. So restrictions say that it cannot be minus 1, and it cannot be 1. So indeed, this is our solution. Okay, one last one. And I've actually taken these problems exactly from your homework. So they're not going to be the same problem, of course, because that's why they give you a different problem. But I'm just using the same ones that you guys could use. Okay, so the last one, 3a over a minus 1 minus 2a over a minus 1 plus 2 over a squared plus 2a. So this is going to be the same exact problem. Don't get freaked out by the denominators when it has more. Think of it like the last one, like this guy here, the y squared minus 1 is going to be the same exact process as that. So I want you to solve the next one on your own and try to solve it without me, and then come back and see if you got the answer right. Okay, welcome back. So we're going to do this process the same way again. So number 1, I find my LCD. So our LCD is going to be this expanded. So if you notice, this one's going to be a little bit different because we have 2 minus 1s. It's still going to be the same exact way. So number 1, our LCD is going to be So whatever is listed in the denominator will tell you what your LCD will be. So it's going to be the same exact process. The next thing we're going to do is going to find a restriction. Well, since they're both -1, I'm just going to do one of them because they're both the same. So it's going to be a minus 1 equals 0. And a equals -1. So it means it can't equal -1. Or +1, sorry. +1. It's already -1. So then the next step we need to do is we need to multiply our LCD by the original. Okay, so now I cross out what I don't need. Well, we have two of the same a minus 1, so we're only going to cancel out one because we only have one denominator. So for both of those, I'm going to cancel out only one. But this one has both of them, so we're going to leave those behind. So what's left behind over here is 3a minus 1 minus 2a minus 1 equals 2. So again, we only take out one of the a minus 1s because we have two of them in the LCD and only one denominator. So now we can distribute. So 3a squared, remember if you have two a's, you square it, minus 3a minus 2a squared minus 2a equals 2. Then I move that 2 over. And I'm going to put the 3a's together, the 3a squares, and then put the 3a and the 2a together, and then this plus 2 on that side, so it's a minus 2 equals 0. So what's 3a squared minus 2a squared? Well, that's just going to be 1a squared. Just negative 3a minus 2a. Well, let me make sure of something. Did I do this right? No. What happens here? So right here, and we have a negative times a negative, so that means this has to be plus 2a, plus 2a. Because if I did a negative here times a negative here, it has to be positive. What about here? We're fine. Okay. So now it's going to be negative 3a plus 2a. So negative 3a plus 2a gives me minus 1a. Minus 2 equals 0. So just make sure your signs are correct. And I find that when I'm problem solving, I always kind of go back just in case to see, and I can usually catch it. Especially when I'm doing a problem like this off the fly, there can be problems along the way. So now we're going to factor. We're going to find a number that multiplies 2, or two numbers that multiply to negative 2, and two numbers that add to give me negative 1. Well, the only two that I can think of is 2 and 1, but then which one has to be negative? The negative 2 is going to have to be negative. So now we just simplify that, setting it to 0, so it's going to be x equals 2, and x equals negative 1. Well, let's look at our restrictions. So we just did 3 through 5 here. What does our restriction say? Well, it can't be positive 1, but it can be negative 1, so that means both of these solutions will work. And that's how you do these problems.